Hi everybody, this is the last week record. This is 15th week. So today we are going to solve some questions and the subjects are over. First example is find the tangent line to the curve y is equal to square root x plus 1 at the point x is equal to 3. Now we have lots of way for this one. First way, let's use limit z goes to x, f of z minus f of x, and z minus x. Yeah. Again, let's write z goes to x and find f of z. It is square root z plus 1 minus f of x, square root x plus 1. And in the denominator, we have z minus x. Yeah. To solve this question, we can multiply with this one, x plus 1, and multiply with this one, square root z plus 1 plus square root x plus 1. So also on the denominator, square root z plus 1 and plus square root x plus 1. You see that on the numerator one, we have z plus 1 minus x minus 1, and the denominator z minus x here, x, and multiply with square root z plus 1 plus square root x plus 1. So finally you see that this one and this one goes, and it is z minus x here, and we have also z minus x here, so they canceled. So finally we have limit z goes to x 1 over square root z plus 1 plus square root x plus 1, and if you put in this z x, so the result is square root x plus 1 plus square root x plus 1, and finally it is 1 over 2 square root x plus 1. So the question is at the point x is equal to 3, so if you put 3 here, finally we have 2 multiplied by square root 4. So it is 1 over 2 multiplied by 2. It is 1 over 4. Yeah, this is the first way. And the other way is easier one. Second way, let's write it here. Second way, we can directly find the delta y over delta x. So it is the derivative of the function, this one, x plus 1 to the power 1 over 2. So if we write 1 over 2 here while taking the derivative and subtract minus 1 to the power, so it is 1 over 2 x plus 1 to the power minus 1 over 2, that is 1 over 2 in the square root x plus 1. Yeah, and finally it says again at the point 3, so 1, 3 plus 1, and 1 over 2 squared 4, and 1 over 4 is the answer. Yeah, this is the second way. Of course, it is easier. So, but in the classical exams, I may ask find the limit of the using limits. So you have to know also limit ones. And derivative is easy. Okay, let's see. And next question. These are the questions for your studying. So it's okay to find different type of questions. The line A goes through the points -2, -1, and 3, 4, abscess 3, and 4 is the ordinate. We know that line B is perpendicular to the line A. Now the question is coming, if line B goes through the point -4 abscess and it's 6 ordinate, find ordinate on the line B when abscess is 4. Yeah, this is the question. Now to solve this question, solution is like that. To solve this question, first of all, we have to find the slope of the A. This is MA, let's say MA. And we have 2 points and we can find the slope. You know, y2 minus y1 and x2 minus x1 is the slope of the A, line A. So it is 5/5, it is 1. Then we know that it is line B is perpendicular to line A, so MB multiplied by MA is equal to -1. This is, we know MA is 1, so MB is equal to -1. Yeah. Last, we have to find the line B. We have to find line B. Y minus 6. We know that the point B goes through the point -4 and 6. So y minus x, and we know the slope, -1. X minus -4. It is this one, minus x minus 4. And finally, y minus x, and y is equal to minus x plus 2. So last question is find ordinate on the line B when abscess is 4. We know that abscess is 4, and let's find ordinate. It is -2. Yeah, this is the answer of this question. Now let's ask another question. Now example is 2 sin pi over 2 plus 1 is the slope of the function f. Now it gives a function with sinus, and we are trying to find the slope of this function. Yeah, the slope of the function, slope of the line, maybe line f. This is function belongs to a line. Yeah, and function f goes through the point 3 minus 1, and the question is find the function f. Find the function of line or whatever. We may also write line in spite of this function, and it's okay. Yeah, solution. First of all, let's find the slope. We know that sine pi over 6, this is sine 30, this is 1 over 2. So the slope is m is equal to 2 multiplied by 1 over 2 plus 1. So it is, you see, 3 over 2, 2, okay, and this is 3, yeah, m is 3. And finally, we know the, again, slope and point, and we can find the function line of function. So y subtract with -1, and our slope is 3, and x multiplied by, sorry, we subtract the 3, and finally y plus 1 is equal to 3x minus 9, and y is equal to 3x minus 10. Sorry. Okay, our line is this one. Yeah, y is equal to 3x minus 10. Yeah. Let's go to another question. Example is find sine 75. Yeah, this is the question. For the solution, we can write like that: sine 30 plus 45. So also we know that this equals sine 30 cosine 45, and cosine 30 multiplied by sine 45. So here's cosine. Yeah, sine 30 is equal to 1 over 2. Cosine 45, we know that square root 2 over 2. And cosine 30 is square root 3 over 2. And sine 45 equals cosine 45. It is square root 2 over 2. And finally, square root 2 over 4. And square root, maybe you can find like that. And this is the answer. Square root 2 plus square root 6 over 4 is the answer for this question. Also, you may write like that. Maybe the multiple choice may be like that. 1 plus square root 3 over 4. Yeah, this may be another choice for you. Now another question. Example is, this is our triangle. This is our triangle, and we have 4 here and 3 here. And our angle is 120, and x is the question. We try to find x. For the solution, we can use the law of cosines. So x squared is equal to, square 4 square and 3 square minus 2, 4, 3, and cosine 120. And if we do the addition and multiplications, whatever manipulations, and here 9 minus 24, you see minus 1 over 2 cosine 120. Yeah, and x squared is equal to 25 plus this one, and 37. X is equal to square root 37 is the answer. Yeah. Now another question. How many horizontal tangents does the curve y is equal to x to the power 4 minus 2x squared plus 2. Have. Yeah, let's find this one. For the solution again, you know the horizontal tangents, if any, occur when the slope dy over dx is 0. So let's write it again. The horizontal tangents, of course, if any, occur when the slope, dy over dx is 0. So it is understandable that it's easy that we are going to find dy over dx, so equals to 0, and dy over dx is 4x cubed minus 4x, so that's equals to 0, and let's parentheses 4x, and we have x squared minus 1. Yeah, for this equation equals to 0, we have x is equal to 0, and here x squared minus 1 is equal to 0, so it is x squared is equal to 1, that is x is equal to 1 and x is equal to minus 1. So we have 3 tangents, horizontal tangents. Yeah. And next one. Yeah, there are two functions u and v, differentiable at x. If the derivative of u multiplied v is 1 minus 2 over x cubed, and another information, we have also delta u over delta x is equal to minus 1 over x squared, and also v is known. V is x squared plus 1 over x. So the question is find u. Find u. So as a solution, to find delta u multiplied by v over with respect to delta x is equal to u multiplied by delta v over delta x and v multiplied by delta u over delta x. We know this one. So left part of the inequality or equality is given as like that, x cubed is equal to, we don't know u, but we know delta v over delta x. Of course, we can find it from here. Delta v over delta x is equal to 2x minus 1 over x squared. It is easy. 2x minus 1 over x squared, and v is equal to x squared plus 1 over x, and we also have minus 1 over x squared as delta u over delta x. So for the next part, we have to do this things. Now, here we have 1 minus 2 over x cubed is equal to u multiplied by 2x minus 1 over x squared. And here we have minus 1 minus 1 over x cubed, minus 1 over x cubed. And we put this one to the left. 2 minus 1 over x cubed is equal to u multiplied by 2x minus 1 over x squared. And to find u, we multiplied by 2x minus 1 over x squared, and here also 2x minus 1 over x squared. Here u is equal to 2 minus 1 over x squared, x cubed this one, and try take the parentheses of x here, and 2 minus 1 over x cubed. It is easily seen. So again, cancel these things, these two, and u is equal to 1 over x is the result of this question. Yeah. Now, another question. We have 4 graphs here. This one is the first graph, and this one is the second graph, and this one is the third graph, and this one is the fourth graph. This one is f of x, this is f prime x, this is g of x, and g prime x. And the given information is, here is 2, and we have also 2 and 3, this point, and we have here 2, here is 1, and 4 here, and here is 2, and now here we have 2 here, and 1 over 2 here, and 5, and here is 2, and here we have 4 and 2, and 2, this one is 7 over 3. Yeah. The question is, z is equal to f multiplied by g. And the question is again, z prime 2 is equal to question mark. Yeah, again, for the solution, we can solve like that. We know that if z is equal to f multiplied by g, so it is f2 multiplied by g prime 2 plus f prime 2 multiplied by g2. Let's find f2 now. f2 is here, it is 3, and g prime 2, here, let's look here, g prime 2 is 7 over 3, and f prime 2, it is 1 here, and g2 is here 1 over 2. Yeah, finally, let's cancel these two, and this is multiply plus 1 over 2. It is 15 over 2. It is 7.5. Yeah, this is the end of this question. And next question, dealing with a volume of a sphere. Volume of a sphere. Let's write the question first. The volume of a sphere is related to its diameter by the equation A is equal to pi over 6 multiplied by d cube. Question is, how fast does the volume change with respect to the diameter when diameter is 2 meters. Yeah, solution is like that. First of all, we have to find the derivative of A with respect to D, because it says that how fast does the volume change with respect to D. So it means derivative of A with respect to D. So it is 3 pi over 6 D squared, and it is like that, pi over 2 D squared. And it says when D is equal to 2, that is pi over 2 squared, it is 2 pi. Yeah, the answer is 2 pi here. And now we can do this question for the last one. Example, at time t, the position of a hot air balloon moving along the air is ht is equal to t to the power 5 over 5 minus 4 t cubed plus 7. Yeah, this is ht. So first question, what is the velocity function? What is the velocity function of this balloon? You know that to find the velocity function, we have to take the derivative of h with respect to t. So it is 5t to the power 4 over 5 minus 4 multiplied by 3 and t to the square, and it is 0. So it is t to the 4 minus 12t squared. It is the velocity function. Next question is, what is the speed? What is the speed? You know speed, by the way, it is at t is equal to 3. The speed is the absolute value of velocity function. So you have to write like that. Speed is equal to velocity function at 3, but it is in absolute value. So it is 3 to the power 4 minus 12 multiplied by 3 squared. So it is 81 minus 108, and this is minus 27. This is an absolute value, and so it is 27. Yeah. And next one. Now the question is, what is the acceleration? What is the acceleration, of course, of this balloon at t is equal to 3 again? For this acceleration function, we have to find the derivative of velocity function with respect to t. So it is 4t cubed minus 24t. You know, velocity function is this one. You may remember from here, t to the power 4 minus 12t squared. So we take the derivative with respect to t of the velocity function, and it is this one. This is the acceleration, and it asks for t is equal to 3. So it is 3 to the power 3 and 24 multiplied by 3. It is 108 minus 72. It is 36. And finally, there's one more question. What is the jerk for, again, hot air balloon at t is equal to 3 again. Jerk is, derivative of a, acceleration with respect to t. So you have to find this 12t squared minus 24, but the question is at t is equal to 3, and it is 3 to the power 3 squared minus 24, and it is 908 and 24. This is 20. It is 84. Yeah, this one is 84. Yeah, this is the end of this lecture. So we will do some more in the online lecture also. This is all for today. See you.